Alright, welcome to your 3.3 video cast. In this lesson we're going to be talking about how you can use an area model and partial products to multiply two-digit numbers. It says the materials that you'll need is a colored pencil, but you're actually, for this lesson, you're just going to use a pencil and we're going to work on our shading techniques. We're going to do some dark shades and some light shades. Okay? How can you use a model to break apart factors and make them easier to multiply? It says you're going to outline a rectangle on the grid to model 13 times 18. Break apart the model into smaller rectangles to show factors broken into tens and ones. Label and shade the smaller rectangles. Use the colors below. Okay? So the first thing that I'm going to do is I'm going to come over here and I'm going to do 10 times 10 because I have 110 times 110. So I'm going to do 10 times 10. So that would be count down 10 this way and count over 10 this way. Okay, so the area of this model, and I'm going to do it pretty light, is going to be 10 times 10. Okay, and then if you looked down, and we know that 10 times 10 is what? 100. So you're going to put the 100 down here in this blue box. So I'm going to label this as blue. Okay. Then we're going to do 10 times 8. Okay, so we have 10 times 8. We're going to come over here to our 8. Because 10 and 8, this is representing 18. And the 10 and 3 right here is going to represent 13. So we have our 13 times 18. Okay, sorry, let me get back on track here. 10 and 8. So I'm going to count over 8. 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to go down here. Okay. So this is going to be 10 times 8, and that's going to be shaded. I'm going to shade it a little bit darker, and I'm going to label that as green. Okay. And then I'm going to do 10 times 8 is 80. Okay. So now we have to come over here and do 3 times 10. Okay, this 3 is representing the 3 ones and 13, and the 10 is representing the 10, or the 110 and 18. Okay, I'm going to go a little bit darker, and I'm going to do 3 times 10 is 30. So in this yellow box I'm going to put 30, and I'm going to just label this as yellow. And then over here, 3 times 8. So I already have 3 down. I need to go 8 over. So that's going to be 3 times 8. So in this box, and it's kind of a pink color. So I'm going to put pink. And I know that 3 times 8 is 24. Okay. Now, I know that I'm going to add up all of these to get the product of 13 times 8. Okay, so I'm going to do 100 plus 80 is equal to 180. And then I'm going to do 180 plus 30. Two plus 2, 210. So I'm going to do 210 plus 24. 4, 3, so 234 should be your answer. So the area of this whole rectangle here is 234. Or in other words, 13 times 18 is equal to 234. Down here on C it says, draw the model again. Break apart the whole model to show factors different from those at the first time. Label and shade the 4 smaller rectangles and find their products. Record the sum of the partial products to represent the product of the whole. So they're basically saying do the same thing again, but use different factors. We know a factor is a number that equals a product. 2 numbers multiplied together. So we have a factor, so a factor times a factor equals a product. So what they're basically asking us to do is to split apart 10 and 3. What's another way that we could split apart 10 and 3 besides 10 and 3? Well, I know that I could do 9 plus 4 is also equal to 13. And now I need to split apart 10 and 8, but they don't want me to do 10 plus 8. They want me to do something else. So I'm actually going to do, to make 18, I could do 9 and 9. Okay. So here in this first box, I'm going to start here and I'm going to go 9 times 9. So 9 times 9. And then I'm going to find the answer to that. 9 times 9 I know is 81. So that box was worth 81. Okay. And then here I'm going to do 9 times 9 again. So I'm going to come from here now over to here. And 9 times 9 again, I'm going to fill this in. 1, 2, 3, 4, 5, 6, 8, 9. 9 times 9 again, I know, is 81. So we have 81 plus 81 down here. And then here I have to come and do 4 times 9. So I'm going to count down 4 and across 9. So 1, 2, 3, 4. I'm going to go across 9. And I know that 4 times 9 is 36. And I also am going to do that one again. So I'm going to do 4 and 9. And 4 times 9 again is 36. So I'm going to add together 81 plus 81, okay, is 162. And then the easiest way for me to think about this is 36 plus 36. 6 plus 6 is 12. 3 plus 3 is 6. Plus 7 plus 1 is 7. So now I'm going to do 162 plus 72 to get the product of the whole thing. So 4, 13, 234. Notice how I got the same answer here and the same answer here. I just broke apart the factors in different ways. So there are multiple ways to find the answer. Okay, number 1 for drawing conclusions, it says explain how you found the total number of squares in the whole model. And I just went ahead and wrote, I broke apart my model into 4 smaller rectangles and found the product of each, and then I added the products. Okay, so basically I just broke apart the rectangle into 4 smaller rectangles, so I made little chunks to get me to my final product. Okay. Number 2 says compare the 2 models and their products. What can you conclude? I can conclude that the products, like I said at the end, I circled them, they were the exact same. And you can break the factors apart any way that you want. Okay, number 3 here is basically asking you which is the easier computation of 10 and 33. Okay, so they're taking 10 times 11 plus 10 times 11 plus 10 times 11. Okay, so they're actually doing that 3 times, because if you added 11 plus 11 plus 11, you'd get 33. Or they're just doing 10 times 30 plus 10 times 3. Okay, so which is the easier way? And I'm going to say that 10 times 30 plus 10 times 3 is easier, because I can use the fact 1 times 3, because that's a pretty simple fact, and what I know about multiples of 10 and a pattern to find 10 times 3, because I know that 10 times 3 is 10 3 times, so I can count by 10. So 10, 20, 30. So I know 10 times 3 is 30. Okay, so I could find 30 here, and then 10 times 30. So I would do 1 times 3 is 3 plus 2 zeros. So it'd be 300 plus 30. And 300 plus 30 is pretty simple to add too, so my answer would be 330. Okay, here they gave you some clues. They want you to find 15 times 24. They've already started breaking apart our first factor, 15. If they put 10 here, how many would have to go here? We're trying to make 15. If we put 10 here, how many would have to go here? 5 would have to go here, because 10 plus 5 is 15. And then over here, our second factor is 24. So they put 20 here, so how many would go here? Good, 4. 10 times, so you'd start here, you go 10 times 20 is 200. 10 times 4 is 40. Then you'd move on down. 5 times 20 is 100. Then you'd move down and over. 5 times 4 is 20. And it says write the product for each of the smaller rectangles. So you're just going to move this information down here. Okay, so the 200 is going to go here. The 40 is going to go here. 120. And then we know that we're going to add all these together to find the total product. Okay, so 200 plus 40 plus 100 plus 20. Oh, not 200, 20. I know is going to be equal to 360. So 15 times 24 is 360. The model shows 4 parts. Each part represents a partial product. The partial products are 240, 120, and I know that when I add these up, I'm going to get 360. Okay. This is just another way to do 2 by 2 digit multiplication. You guys already know the standard way. I would like for you to try these using the partial products method. Okay, so you're going to go and you're going to do numbers 1 through 5, and you're going to focus on numbers 3 and 5 first, and then you're going to finish with these. Don't forget to go from here to here, here to here, then go down here, here to here, here to here, and write your answers there, and then you should have 4 numbers that you're adding together in the end to get your answer.